Hello everyone, welcome back to day 3 of our masterclass series. I'm so excited to cover today's class about agent framework. Yesterday on day 2 we cleared our basic fundamentals about what goes on inside an AI agent. That's exactly the brain, the memory, the planner and the tools. But today we are going to talking about the real world execution. So how do you actually code these components? Today we will understand why we need special agent frameworks, explore the top choices available in the industries, and see why LangChain and LangGraph completely stand out from the crowd. If you are an absolute beginner, do not take any tension. We will go very slowly and simply. Let's start the engine. Okay, let's start with the puzzle. Imagine you want to build a giant, beautiful Lego castle on your bedroom floor, but instead of buying a box of Lego bricks, imagine I gave you a bucket of hot melted plastic and told you you have to mold every single brick by yourself and wait for it to dry and paint it before you can build. What would happen? You would get so tired, your hands would be a sticky mess, and you probably give up in 10 minutes. This is exactly what happens if you try to build an AI agent from scratch using raw Python code without any help. Software engineers calls this boilerplate and spaghetti code. Your script becomes a tangled bowl of messy Maggi noodles because you are manually writing code just to track history, clean up text formatting, and fix API glitches. There's another huge problem, vendor lock-in. Don't worry, that's just a fancy tech term that means getting trapped. If you write your code completely tailored to one AI company, let's say you're going to use OpenAI model or Anthropic cloud model or Gemini Flash model. If you write your code completely for one company and tomorrow a brand new super super fast, completely free open source or another AI model comes out, you can't use it because you would have to throw your entire script into the bin and start from a zero. That gives a massive tension to developer because every time a new model comes or you are changing the model provided to one model provided to another model provided, you have to rewrite the whole thing, right? So an agent framework like LangChain is your ready-made box of Lego bricks. It gives you the pieces of pre-molded and ready to snap together. So if you want to swap a cloud AI cloud model for another model, or if you want to tap into a local model running in your machine, it can easily snap into that piece of code. You don't have to worry about that. You don't have to rewrite any of the logic again. So that's the beauty this agent framework gives. So let's look at what are the agent frameworks available today. So there are so many agent frameworks available today that I don't want to go through each and everything. Just pick up the top three widely used agent frameworks. The first and for the most widely used model agent frameworks are LangChain and LangGraph ecosystem. It is the absolute king of the industry. With there are many thousands of developers using it. It has the biggest library of tools and plugins. The second mostly used we have multi-agent frameworks like CrewA or Microsoft AutoGen. These are designed for scenarios where you want a team of AI agents to solve problems together. For example, one agent acts like an SEO researcher and another agent acts like a content writer, and they talk back and forth so that you can create a multi-agent framework systems. The third is the Pydantic AI, which is a new framework designed for strict data formatting. If you want to make sure that your AI generated output matches your system's data rules without any deviations, developer can look at these Pydantic AIs. For general, versatile, and commonly used applications, LangChain remains the absolute best starting point. That's what we're going to focus it today. Let's do a deep dive into the superstar of agent framework, LangChain. What is its secret superpower? Think of it's like a universal travel adapter. Think about a scenario if you're traveling from India to America, Europe, or Australia, and if you try to carry your power adapter for your laptop charger, when you try to go and plug it into the electric wall, you will not be able to use it because they use a different wall adapter there. So what do you normally do? You find a point, you buy a universal adapter so that you can use it in this country. That's exactly LangChain does it, right? So Lang, every AI company has a slightly different way of they want you to talk to the systems. Basically, the API they got a different specification. If you want to call OpenAI APIs or Gemini APIs or on Anthropic Cloud API, they have a different way of calling the API spec. But with the LangChain, it provides a unified layer. You write the code only once and the LangChain translates into the behind the scenes. You can switch from massive internet any of this model, cloud model, to a completely free private running model directly inside your laptop memory without changing your main code because LangChain does the translation for you. On top of that, it comes with a built-in memory boxes so that AI agent doesn't forget what you said 2 sentences ago. And instant plugins for it, and also it comes with plugins for Google search, YouTube calculator, and file readers. It handles all the boring plumbing works so that you can focus only on building the fun stuffs. So it got the existing LangChain ecosystem consists of thousands of pre-built third-party tools like for Google search, SQL databases, and Excel readers. So you don't have to worry about building all these tools, just focus on building the fun stuff. Uh, Now, how do we actually write this code? In the old versions of LangChain, it was a little bit clumsy, but recently they invented a super cool syntax called LCEL, which stands for LangChain Expression Language. Don't worry about the long name, just look at the code block on the slide. Do you see that straight vertical line symbol between the words prompt model and standard output processor? Honey, it is called pipe symbol. I think everyone knows it. I want everyone to imagine a physical pipeline running through a chocolate factory. At the start of the pipeline, you drop in raw ingredients like the pipe carries it to the oven and that then to the mold and out comes a perfect dairy milk bar at the end. LCL does the exact same thing with the data. Look at how beautiful that single line of code is chain equal to prompt pipe model pipe standard output parser. We are telling the computer take the user's question, pipe it directly into the AI model's brain, and then pipe that out answer straight into the clean text cleaner so it displays perfectly on the screen. And here is the secret feature. Because it's a smart pipeline, it has built-in safety nets. If the internet flickers or or the cloud model gets stuck or you don't get the response back from the cloud model, the pipeline doesn't crash your game. It instantly route the data to a backup model running on your local machine or other model provider. It makes your code incredibly strong with almost zero effort. All right, time for an interactive mental challenge. I want everyone to close their eyes for a second and picture a train moving down a single track. It can only go forward step by step. For example, from station A to then station B and then station C. This straight line track is exactly how a standard chain works. It is fantastic for a simple task like reading a paragraph, translating into Spanish, and saving it in a text file, point A to point B to point C. But now let's imagine a harder task. What if you ask your AI agent to write a Python computer game for you? The AI writes a code at station A, then at station B, a code tester tool runs it and says, oh no, there's a syntax error on line 4. In a standard straight line chain, the train has no way to turn around. It can't go backward. So what happens? The entire program crashes. Seeds a dead end and your project breaks. Think about how you study for a school exam. If you get a question wrong, do you just stop playing and cry? No, you look at the mistake, go back to your textbook, fix your understanding, and try answering again, isn't it? Real intelligence requires loopbacks, second chances, and circles because straight pipelines can't turn back. The developers built a LangGraph to give our AI agents the power to loop backward, correct the prompt, and try again safely. So instead of straight train track, LangGraph lets us draw a complete sprawling treasure map for our AI agents. To build this map, we only need to understand three simple concepts: nodes, edges, and shared state. Let's break them down easily. First, look at the nodes. Think of a node as an action station on your map. Every node is just a small, simple Python function that does one specific job. One node's job is to talk to the LLM brain. Another node job is to click a web search tool. The third node job is could be calculate some numbers. So look at the second one. We have edges. Edges are the roads or paths connecting our action stations. But these aren't just normal roads. They are smart paths with logic gates. For example, an edge can look at the AI agent's work and say, if the code has an error, take the red road backward to the coding node. If the code is perfect, take the green road forward to the finish line. Third, we have the shared state. This is my absolute favorite part. Imagine your agent is walking through this map wearing a digital backpack. Whenever node does some work, it writes its finding down on a piece of paper and drops it to the backpack. Every single node on the map can reach into this shared backpack to see what happened in the previous steps. So this ensures the AI agent never loses its memory or gets confused about the mission. So every time when agent finishes a task, it writes into the shared state, and the next agent read from the shared state. They use it across the shared state used across all the agents. When you snap LangChain and LangGraph together like a superhero roommates, you get three incredible features that would take months to code completely by yourself. The first one is infinite loop control. Imagine an AI agent gets stuck in a loop where it searches the web, hits a weird error, tries again, gets the same error, and keeps doing this forever. If it is an expensive cloud model, it, it could run up thousands of dollars in your API bills while you are asleep. LangGraph stops this instantly. You can set a rule that says, hey, if you loop through this path more than 10 times, pull the emergency brake and stop it. The second feature is human in the loop gates. Imagine you build an agent to manage your pocket money or send emails to a teacher. You don't want the AI agents to send something silly by accident. You can program a roadblock into the graph that says pause here, freeze the backpack, and send a pop-up confirmation to the user's phone. Do not cross this edge until a human clicks approve. So you can introduce a human in the loop gate until as the human actually manually approves it will not take an action. The third feature is like a science fiction movie, time travel debugging. If your agent runs a complex task and breaks at the step 15th or some other step, you don't have to restart the whole process. You can literally pull up a visual timeline, rewind the agent's brain state to step 4, look exactly inside its memory backpack at that moment, change a single sentence in the prompt, and hit play to see if it succeeds. It completely eliminates the debugging tension. So you can go back, you can review the historical states, modify the input variables in mid run, and you can receive the actions execution effortlessly. Let's look at the comparison table on between different agent frameworks. So we are looking at our options across three important categories. If you build an agent using pure custom Python, you absolutely freedom of doing whatever you want. But you have to write every single tool connector, sharing them, writing the shared memory states and building a planning and controller. And you have to introduce a loop gate by loop gates, human in the loop, and everything you have to write code by yourself. It's like building your own phone from scratch just to make a call. If you use high level toolkits like Crew AI, they're fantastic for setting up quick conversational characters, but they hide all the routing tracks behind the scenes. You can't see the roads on the map. But when you combine LangChain and LangGraph, you get the absolute ultimate balance. You get granular control over every single node, station, and road arrow on your map. Plus, you have a massive warehouse of your 1,000 pre-made integrations readily available to do deploy. That is exactly why the tech companies, professional AI agent developer and enterprise engineer choose this combination to build real AI agent systems. Brilliant job, everyone. You successfully completed day 3 of our masterclass series. You now thoroughly understand why frameworks are essential and how LangChain and LangGraph work together to enable complex workflows. Let's do a quick lightning recap of what we learned all this time so far. Frameworks are essential because they stop our code from turning into a messy Maggie noodles and save us from vendor lock-in. LangChain brings the giant box of pre-built tools and adapter, while LangGraph gives us a treasure map, the shared backpack state, and the power to loop safely without crashing. Tomorrow, the day 4, we will move into hands-on coding. We will be explaining how to set up the Olama model in your local machine, how to pull the open source model, how to set up the machines to run the open a source agents in your local machine. Thank you so much for your time, and I'll see you tomorrow.